Welcome
to the joy of coding.
Hello, and welcome to episode 411 of The Joy of Coding. My name is Mike Conley. It's so good to have you here. I'm back from vacation. It's been a little while. It's been a couple of days. I hope you've been well. I got some sun. I got to relax a little bit. I have an aunt and an uncle who have been formative in my sort of like computer science career. They're the ones who initially got me interested in programming. They're both computer scientists themselves. I was with them. We got to talk about nerdy stuff during part of our trip. That was very nice. And yeah, I wanted to give them a quick shout out. And if you yourself have been having a break, a holiday, and you're back from it, welcome back. And if you've not yet had a break, consider taking one. If you've got a break coming up, I hope you have a good one. And just say in the if you've got holiday plans, let us know in the chat. Maybe something interesting will come up there. All right, let's start by sharing my screen. Hey, it's July 30th, 2025. Holy cow, we are blasting through summer. I got about a month and a bit of summer left, at least here in the Northern Hemisphere. Yeah, it's episode 411. A reminder, no plan survives breakfast. I think I know what I want to work on today. I think I know what's going to go down, but I could be wrong. I could be mistaken. We could be sidetracked or sidelined. Who knows what'll happen? It just occurs to me that I should double check and make sure that the stream is actually working, because I didn't do that before I launched. So let me just make sure that things are going through. Yes, things are going through. Okay, good. Things are going through. Yeah, no plan survives breakfast. Things might go wrong, and that's okay. In fact, something has already gone wrong in that I gave a sort of an outline of what I wanted to work on Mastodon earlier today. I had said that I wanted to get rid of some tech debt and some new tab stuff. But late breaking, there's a thing that we've discovered that I worked on that's broken, and I want to try and fix it. So I want to talk a little bit about that today. We're going to be working on fixing Moz cached OHTTP protocol handler for SVG images, which are actually documents. And so for that, we're going to be talking a little bit about OHTTP, also known as Oblivious HTTP. We're going to talk about the Moz cached OHTTP protocol that I added. And then we're going to try and fix this and sort of figure out what's going wrong, at least. I have a hypothesis. I don't actually know if my hypothesis is correct. That's the whole point of a hypothesis. We'll test it and see if we can get things fixed. I'll explain the problem. Maybe we can write a test case. That'd be good. And then we should... agenda only going up till 408. Uh-oh. Did the agenda not... Let's see. Is the agenda broken? Joy of Coding. Episode agenda. 411. It's right here. Here's the agenda. It's possible. Are you looking at the episode guide? No. 39. It's up to 397. I've got some episode guides to merge in. Haven't done that in a while. But it should be going up to 411. Maybe shift reload there, nerd bloke. Under episodes here in this index, you should probably see 411 is in the list. Wow, what's some of this stuff? Is this my template get put in here? This is wild. Some of these are like, I don't know what some of these are. But there you go. There you go. All right, let's gap between 408 and 411 though. Oh, there's a gap? 8? Oh yeah, there is a gap. Did I not? Oh, I didn't export these. Here, let's fix this. Let's fix it. I have to put the exported tag or else they don't go out. I must have missed it. And that reminds me, we didn't do our Keanu codes thing. So let's do that. And this is still running. Hopefully that hasn't been playing for you in the background. I'll go ahead and see if I can get these synchronized now. So let's go and do Keanu codes for HTTP code 411. Let's see if we can find one. Let's see if this will spin and synchronize. Let's see. Did it synchronize? 408. It did not. I've got to like go and touch each of these, I guess. So I'll put another beach umbrella there. Does that go out? 410 and then 409. I'll just put, I'll turn that into an exclamation mark. And 409 is there. Thank you very much. That's those should now be out there. I apologize. Those are now out there. Okay, so let's see what HTTP status code 411 is. Let's go to Keanu.codes. See if this is still up. 411. Is there a status code? Yes. Length required. This is a hilarious image. I don't know what the context of this. Oh, you know what? I do know what the context of this is. This is from a third Bill and Ted movie, I'm pretty sure. This is what his character Ted looks like while he's in prison, I think. 411, length required. So let's go ahead and copy that image. Error 411, length required. There's the image. So what is length required? Let's pull it up on MDN. Length required is a client error response that indicates that the server refused to accept the request without a defined content length header. So I guess in certain cases, the server might require the client to specify the length of what it is that it's requesting. So when sending data in a series of chunks, the content length header is omitted, and at the beginning of each chunk, the length of the current chunk needs to be included in the hexadecimal format. See transfer encoding. So for example, in a chunked post request, the following request is sent chunked, which is the default method of sending data in some cases, such as when writing to streams. So in this case, the server is expecting a request in one part with a content length header and returns a 411 response. Oh, that's interesting. In this case, it's it expected a content length to come out. All right, well, there you go. Today I learned. And I think this is a very appropriate image. Length is required here, although it does kind of look like Keanu's got the length there. It's just all kind of bunched up in his midsection there. All right, today we learned something. So let's learn something else. Let's talk about OHTTP. Let's talk about the Moz cached OHTTP protocol, what we're trying to do here, and the problem. Let's see if we can reproduce the problem. I think I've got a build here. So let's start with the problem, or not the problem. Let's talk about what is OHTTP and why do we want to use it? Well, OHTTP is an attempt to solve a very interesting problem, which is that Mozilla wants to serve, for example, these images from which we are actually proxying from the actual publishers, from like the Hollywood Reporter. We proxy the request. Like Mozilla receives the request from the client to get that image. Mozilla then makes the request for the image and then caches that image so that we're not like bombarding like the Hollywood Reporter with all these image requests. We cache it on behalf of them. But we want to be the best in terms of protecting a user's privacy. And one thing that we're going to be doing over time, that we're investing in, and maybe you can sort of get a sense of it whenever you look at my new tab page, is that we're trying to make the new tab page more customizable. We're trying to make it so that you can pick and choose the things that you're interested in, the kinds of stories that you're interested in, the topics that you're interested in. And so that makes the new tab page maybe more useful, more relevant to you. But at the same time, that leaks information about you. Like if you are interested in, I don't know, let me pick something. There could be like, it could become very clear that you're interested in like, I don't know, bankruptcy protection or some topic that's kind of sensitive. Maybe a particular health issue is one of your interesting topics. And, you know, if Mozilla starts receiving image requests for stories that are for a particular like health issue or you know, I don't know, sensitive topic, that potentially leaks information to Mozilla. So in this sort of like privacy model, Mozilla is the adversary. Now keep in mind, like Mozilla does not make use of that information. We do not want to know really what you're interested in. We want that to be your information. We still want to serve you, but we want to make it so that there's kind of like a user verifiable guarantee that you can request these images from us, and maybe like the fav icons for the different publishers, and that Mozilla doesn't know who requested the images. That's the thing, because like when you make the request to our CDN to get these images, you do it over what's called raw TLS. And raw TLS, or like just TLS. So we can see the IP address, unless you're like VPN or something. We can see who the client IP is. It's a standard HTTP request over TLS, so like SSL, and it's where we see the path of the image that you want, and the user agent and all the sort of stuff that comes by default with the HTTP request. And so we want to try and protect the user, and hide from Mozilla. And in this case, actually, from Google as well, because the CDN is hosted on Google Cloud Platforms from GCP. So we want to mask the user's IP address and user agent and basically everything about them, and just allow them to get access to the image without revealing who they are. So how do you do that? How do you do that? I mean, one way you do that is like. A naive way of doing that is with a proxy. You could proxy the request, but then the proxy kind of figures out what it is that you're doing. You know, like if you're a proxy and maybe you're like Mozilla VPN or something, or Mullvad. Now the good news is that Mullvad, which powers Mozilla VPN, does it all. Like I don't think they do it. They don't do any logging. We audited them. They're very, very great. I like them. But say you're a less than trustworthy VPN provider or proxy provider. You can kind of get a sense of the traffic going over your proxy. You can like see who's connecting into where. So like you've moved the trust, the sort of the trust boundary a little bit, or you've moved the threat boundary such that you have to really trust your VPN provider. The people on the receiving end of those requests that the VPN is making on your behalf get to just see the VPN as the one making the requests. They do, I think, like, they don't do anything about the headers necessarily. Like, if you send something, your user agent string in a network request will not be changed by your VPN. So they just kind of like mask the IP address and not much more is what a VPN does. So we think we can do better. And Mozilla invented this technology. There was a Mozillian named Martin Thompson, one of my colleagues, very smart, and he's worked with other people on this. And there's this technology that he designed called Oblivious HTTP, and this is a standard that is ratified by the IETF, the Internet Engineering Task Force. This is fairly recent. January 2024 is when this was published. Martin Thompson and C.A. Wood from Cloudflare. And this is a very long document. You're welcome to read it. I'm going to do my best to try and explain what Oblivious HTTP is and how it protects you. So here's the IETF RFC, and now I'm going to try and explain briefly what it is and how it tries to protect you. And so what I'm going to do is I'm actually going to try and change. I'm going to change to my camera. I want to be able to draw. So I'm gonna, how do I do this? I need to share a different screen. I need to share my, this may not work. I want to share a different window. Did that work? Yes, okay. I'm gonna move my microphone. So this is my drawing tablet. I'm gonna move out of frame from my camera so I can lean over my drawing tablet and I can draw. Hopefully you can see this. Okay. So, Oblivious HTTP. So let's say I'm going to bring up the drawing size a little bit here. That's too much. You are a Firefox client. And in the normal state of play, when you make a network request over TLS to say like the CDN, this is like the story image CDN. This happens over TLS, and TLS means that like there's a bunch of nice cryptography that makes it so that an eavesdropper, an attacker, cannot, what's an attacker going to look like? Can't actually listen to the traffic going between the two. Now, someone who is maybe, on your network might see that you are making a network request. They can see that the connection is being made from one computer to another, but they can't necessarily see, they can't see the traffic that's going over the wire. The actual request itself is hidden. But someone, for example, on your home network, or maybe you're in a cafe or something, could see that you've opened a network request to this machine, so they could know, for example, that you're making a request to a computer. It's some computer somewhere, some IP address somewhere. So that's TLS. Now in this model, the story image CDN, which we'll say is also Google, that is like, it's running on GCP, but it's Mozilla who's actually like operating the CDN. We pay for some GCP stuff, the CDN capability, and we sort of manage it. We have access to a bunch of things. There, in theory, we get to see the IP addresses of who's connecting, if we were to like look at the logs, and we could also see what the images are that are being requested. So, normally, whenever we're we're the ones setting up the stories on the new tab page, that's not a problem because everyone gets the same set of stories in a particular region. Like all of Canada gets the same set of stories. So generally that's fine. That's like not a lot of like what we haven't leaked much. If we've leaked that you're in Canada, well, your IP address is already leaking that. Like your IP address already like tells the recipient where you are, more or less, like to sort of you can get the city that a person is in from their IP address, for example. And so we can do better once the image requests start becoming maybe a little more sensitive. So for example, let's say you start customizing your new tab and your interests start to really be represented on the new tab page. Well, now all of a sudden you've got this kind of like interest identifier thing that exists now because of your, the way you've customized it and the way it's learned maybe what you're interested in and whatnot locally. And that is sensitive information. We wouldn't want to necessarily leak that to Mozilla. Like in the worst case scenario, let's say there's like a data breach of the CDN logs and someone's able to go like, oh, a person with this IP address is really interested in, I don't know, bankruptcy protection or something, and then they could weaponize that against you. I know that's like far-fetched. I realize this all seems quite contrived, but I mean, Mozilla, to a fault, will twist itself into knots in order to protect the user, protect the client from threats, even when those threats are theoretical, like Mozilla being like the antagonist. We'll game it out that way, and we'll go like, okay, we can do better here. We want to have like defense in depth, and we want to do our best to protect the user's interests and information. So how do we do Mozilla for that? Says Smurf D. Not sure what Mozilla for that means, but go ahead and elaborate if need be. So how do we do this? So let's go back to heart Mozilla for that. Oh, I see. I in the bridge, I guess it stripped out your little emoji or whatnot. So what is OHTTP and how is it going to protect the user in this particular model? Okay, so that's no OHTTP is above. Now OHTTP. In this model, you've got your Firefox client. Whoops, can I spell? Okay. And then, critically, you've got two extra pieces in the sort of the chain. You've got what's called a relay. Critically, this relay is run by a third party. You know what? I'm gonna call it an OHTTP relay. And that, right now, we pay a company called Fastly to provide this relay. And then you have something called an OHTTP gateway. And that we run, Mozilla runs that. So this is like Mozilla infrastructure. I'm going to put a box around like Mozilla infrastructure, which may include like GCP stuff. And then in there, you've got like your story image CDN. And so what happens is the client makes and caches a request to some configuration endpoint. I think it might actually be the gateway that provides this. This is the part that I'm a little fuzzy on. I'm pretty sure what happens is it makes a request to the gateway because the client knows the address of the relay and the gateway. And then that request, the response will include cryptographic information that the client knows, that the gateway knows, but the relay does not know. And then what happens, so I'm going to get rid of that arrow because this is the more important part. The client then wraps up the request in the special package that goes to the relay. So it's in a special package, and that special package does not say what is being requested. All that the relay sees is that this client with a particular address, 148.221.344, is sending it some kind of payload, and that the payload is meant for the Mozilla gateway. That's all it sees. And the relay is configured to know what relays are allowed, what gateways it's allowed to talk to. So it doesn't know what service, because like Mozilla has a number of things using OHTTP, including like the Glean telemetry stuff. I think those are for a while there, the shopping sidebar was using this stuff. So like the fake spot shopping stuff was using this. But that service is done now. But the relay doesn't actually see what service this is for. They see an encrypted blob, an encrypted payload, and the fact that it's addressed to the Mozilla gateway. And so its job is to then send that along to the gateway. So the encrypted blob comes over, and so the gateway, Mozilla's stuff, sees that it was Fastly's IP address, say 101.3433, somewhere in like, I don't know, Atlanta, Georgia. I don't know where their relay is located. Just sees this request come in, and the gateway has the cryptographic information necessary to decrypt the request and take a look inside of it and go like, oh, this is actually for an image request from the image CDN. So it goes ahead and forwards that to the story image CDN. The storage image CDN also sees that it's 101. Whoopsie daisy. Oh, I keep hitting this button on this stylus. 101.3.4.33. So the Fastly relay is the IP address that the story image sees the request from. I think there's like some forwarding headers or whatnot that it's using, because like it knows to respond back to the gateway with the response on behalf of this addressee. And so the response comes back, the gateway re-encrypts that into a blob that goes back to the relay. So this is the response. And so the relay just sees this opaque response come back. They don't know what service, again, it was for. They don't know what's in it. It's just like, here's a payload. And they, because this request is still open to the relay, then respond to the requester with the encrypted payload, the encrypted response, which the client can then decrypt and treat as if it had made a direct request to the story image CDN. And so what are the privacy properties of this? One thing is that the Mozilla never learns who sent it the request, and the HTTP headers, like the user agent, all of that sort of information, it just looks like it's coming from the Fastly relay. That's what it looks like. From the perspective of Mozilla and the gateway, which Mozilla runs, the requests all look to be coming from this Fastly relay. The client gets the information it wants. It gets to get the image, but Mozilla doesn't learn who requested it. So the user gets the image, the client gets the image. Fastly knows who's making the requests. Fastly sees the IP addresses coming in that's making requests to the Mozilla gateway, but it doesn't know what for. It doesn't see the contents of the request, like that it's for a particular image. It just sees who, but not what. The gateway sees what, but not who. And then the client gets what they want. That's Oblivious HTTP kind of in a nutshell. And if I go back to the other screen, hang on, I should have made this easier. If you go back to the RFC here, this is kind of like a rejigging of the thing that I just drew. So like client relay request plus the encapsulated request goes to the relay, makes a gateway request passing along the encapsulated request. Gateway decrypts the encapsulated request, makes the request to the target resource. Response comes back from the target resource. Gateway re-encapsulates it and then sends that response to the relay. Relay responds to the client. Client unpacks it. Bada boom. That's the thing. That's what we're trying to do. Some pretty nice privacy properties. Now, this isn't free. There's a trade-off here. One is Mozilla has to pay Fastly. We pay for this. This is not a thing that we make money off of. This is a thing that we lose money on. We spend money to protect users to do this. So that's one thing. The second thing is there's latency. There's latency because of the extra bits and pieces in the layers here. And finally, there's the gateway resource is doing a bunch of decryption and a bunch of networking, so that's additional compute on top of the stuff that we're paying for like our relay partner. Because like right now we're using Fastly as our relay partner, and they're a great partner. But you could plug in like an OHTTP relay is a fairly simple thing, and you could plug in any other relay that's configured to talk to your gateway. So this is a fairly flexible system. There are also more sources for failure, right? Like by adding more layers here, there are opportunities for things to go absolutely sideways. That's right. Like if one of these two pieces, if the target's resource is down, but the relay is, if the relay is down, but the target is up, it'll seem as if the target is down. If the gateway is malfunctioning, but the relay and the target are up, like it's just more points of failure. That's part of the trade as well. Okay, so that's OHTTP. So fast forward to now, and that problem I was talking to you about earlier, which is, wanting to request images. Well, the way that OHTTP is, the current implementation that exists in the tree, we have this module that exposes Oblivious HTTP to the front end, to privileged code. But it does it in a way that is indistinguishable. It's like almost a drop-in replacement for fetch, and so that's not very nice for images, because when you use a fetch or something, you can get back like a blob or an array buffer or something, and then you could like create an object URL and assign that to an image. But there's like a bunch of hand-holding and manual gunk that you need to do. And what would be ideal is if there was just a way of taking an image tag, a standard image tag, and then having the source be set to something special that says, now request this over OHTTP. And that's what I wrote. I wrote this thing called Moz OHTTP, or Moz Cached OHTTP Protocol. And I documented it. And you can read the documentation here. Now, to be clear, this is not a thing you can use on your own website. This is a privileged protocol that only the privileged browser code can use. And so the basic usage is you can like set an image to be have its source be Moz cached OHTTP, then new tab image as the host, and then in the query params you specify a URL, and then you like URL encode a URL. And that's hilarious because the proxy that we use to request images for the like stories on new tab is already using a pattern kind of like this, where you're making a request to the image proxy, passing in the actual source image as an argument. And so we're putting like multiple hats on here, where we take like that URL for the image and you encode it for the URL for the proxy, and then we're encoding that again for the cached OHTTP layer. it seems like it's a lot. It's a lot of bells and whistles, and there's probably room for optimization here. One of the things that we might do, for example, or something that if Oblivious HTTP really kind of takes off, is that Google, for example, might start running their own gateway for their services. In which case, we could then use we could run. We could pay Fastly to run the relay, but we don't have to pay the gateway costs, and then like we could potentially change some of the rules on who, like, you talk to the relay, talk to a different gateway, but it talks to like there's lots of room for flexibility here. Anyways, that's how it works. So we can set that as an image source, and it has to be over SSL. And there's this key word in the protocol, which is cached. So like I said, there's like a cost here for making requests and going over the relay and the gateway. There's a cost to Mozilla and there's a cost to performance. And so we want to aggressively cache responses. And this is true for images in particular, because these images tend to not change. And so one of the things that the fetch mechanism did not do, I linked to it before. The fetch mechanism does not cache the responses. So that's what this does, is it will take the response that comes back from the server and it will write it into the network cache. So that subsequent requests for that same resource, it'll check the cache first, and if it finds that there's like a valid cache entry for it, it will just read from the cache rather than attempting to make the network request. And it won't do what's called the race cache with network optimization, where it will like race the two or anything. It'll always check the cache first. So that's the TLDR for Moz cached OHTTP. If you want to read up more on that, I highly recommend reading the documentation. So now let's get to the problem. And this image is hilarious. I'm loving this Keanu image. So the problem that was made apparent to me, let's actually use the Moz OHTTP. Let's set up to. I actually have a build. Let me switch to my artifact builds, because that one's configured to use our staging stuff. And I'll show you the problem. If anyone has any questions about OHTTP, I can try and answer them. I'm not. I would say at this point I'm fairly comfortable with the concept, but I wouldn't call myself like a world-class expert in the field, but if you've got questions, I can try and answer them. Okay, so what I'm going to do is I'm going to request this image. Well, actually, first, before I do that, let me clear my cache, clear the networking cache. So I've done that. And I'm going to now make a request for that image. Check. Hopefully you can see this. I'm going to make this image. I'm going to attempt to make this request for a particular SVG. That's critical. An SVG image, and then I'm going to append the resulting image to the body of the document. And did that work? There it is. Sorry, it took a second there. It's here. So that works. Now let me reload, and let me do it again. Now check that out. That right here, in the biz, we call that a broken image. Now, how come that's happening? That's the mystery. The very first request for the image will work, but subsequent requests will fail. Now, that's true for SVG images. Let's try it for one of these images here. We'll use the Pocket CDN thing. So let's try it for like a PNG image. Let's encode the URI component, and we'll say that this is like that PNG image URL equals that, and then I'm going to say I dot source equals Moz cached OHTTP : / new tab image / URL equals plus PNG image URL. And so that request will go through. That's fine. It's a little low res because I requested the lowest res one, but it's fine. And I can do that again. Let me do that again. We'll do that part and then this part. And that works. So subsequent like PNG requests are fine. But the SVG request is the one that's broken. So every time now that I will request this SVG, it will be broken until I clear the cache or the cache expires. So why is that? Well, if we take a look inside of the cache, so this is, if you go to About Cache, you can take a look at the, this is sort of like the diagnostics area for the HTTP cache. And we can find our entry here. We can see that we've made 3 requests for it. We are storing stuff. We are storing the SVG. This is the contents of the cache. The SVG is in there. But if you actually make a request to the image itself, like without using OHTTP, and then we go to About Cache again, and we find the raw image. Where is it? This one. How do I cache this? Yeah, here we go. There's a bunch of extra information, and I suspect this extra information is required for documents that are held within the cache. So that's the thing. SVGs are special because they're technically documents. They're not just blobs of information. They are actually documents. And I suspect that either the head and response headers or the security info that kind of comes with the network request, and maybe some of these other things strongly framed, I don't know. I think those are required for the image, for SVG images. So let's see if we can update our mechanism to try and supply some of this information when it writes to the cache. That is the goal. And this is going to be a little bit of a pain in the butt, I think. No IO before bedtime writes, that weird. I wouldn't expect the cache to care what it's caching. I mean, in this case, I think yes, it does in the event that it's a document, because it needs to know how to treat the document. It needs to know, I guess, like the security context. And maybe critically, I'm wondering whether it cares about the content type. You know, for documents, I wonder if that's like the kind of important part here. And maybe that's all I need to supply is the content type. But I'm going to see if I can supply all of the response header information. That's where I'm going to start. It's just the response header. Let's see if we can inject that into our cache when we write it. So let's open up our source code, Moz OHTTP, cached OHTTP protocol handler. This is the code that I wrote. Go ahead and collapse that. And the part that we care about, I think, is when we don't make a cache request, we actually make a network request, an actual real network request. That happens right here. And then we stream the response into the cache for next time. We need to, when we're doing that, also include the header information. And so what I'd like to do is, if possible, go to new channel, the execute the OHTTP request part here. I think what I want to do is look at the response listener, and I want to see whether or not we can look at the, I want to examine the request if possible. Actually, maybe I can do that right here in our dev tools without having to like add any logging. Content type. It looks like I was already trying to do some of this. So I'm going to I hope that this isn't going to cause a crash, because sometimes if you break in the midst of a network request, the browser will crash. Like if you hit a breakpoint. So let me actually just log the request. And then what I'm going to do is I'm going to clear our cache again. And then we're going to go ahead and request our image. And here is the request that we got back now, or the request that went out. NSI request. Is there a response status? 200 response status text. It's not implemented. Response. Are there headers? Get response header. Content type. Yeah. So right now we tried to get the response header. I don't know if that, oh, that's interesting. I wonder if we didn't, we're just not writing it into the cache when we do that. Like, would that be enough? If I were to log here, content type plus content type, and let's repeat that experiment. Clear. And let's repeat our experiment. Content type. So let's see if we could just write that header into the cache. Because I believe there is in the interface for cache entries. I believe there's a way of setting this extra data. In this case, it was request original response headers. Maybe if I could just put that in and put in content type, maybe that'd be enough. Or maybe I also want content length, original response headers. So what I'd probably want to do is visit each header. I believe I can do that on a channel. Visit response headers. Call SMS to visit all response headers. Call SMS to visit all response headers in the form and order as they have been received from the remote peer. Now, what do we do whenever we actually set this cache value of original response headers? What one are we using? Head, which is response head, which is coming from what? M response head. So it's just this value M response head, which is presumably a string, right? Like, is that, what is this? No, it's a thing called an HTTP response head. So what is original response headers versus visit response headers? Let's see. Original response headers. Visit original response headers. What's it gonna do? It just visits each one of these versus visit response headers. It's going to visit and it's not going to filter. And so whenever we get the, I have a feeling they're all going out. It's the original response headers is what we want. So let's go ahead and try and do that. Going to do this dot process headers cache stream update port request. And maybe that actually should be in process cache control, process headers, process cache control. No, this is no, I regret that. This dot process headers, because what is this one doing? It's calling write cache entry. Oh, write cache expiry, right? That's different from writing the headers. Process response headers, cache stream update port request. Okay, so process cache control is over here. We're going to put this one here, cache stream update port, and the HTTP channel. We're going to copy the doc string, sets the request headers on sends a signal to write the request headers into the cache entry. Or maybe just attempts to write the request response headers into the cache entry. Sending cache request oh, maybe that's easier. Response headers to the parent actor. HTTP channel with response headers. Okay, so what we're going to do is we're going to early return if for some reason we're not an HTTP channel. And then we are going to, because we rely on being able to call visit original response headers, HTTP channel visit original response headers takes a visitor. Let's see if we can find an example of this being used. I see. And it gets a name and a value. So you get an object here. Let headers equals, we're going to just have this opaque object. And then we are going to header, which is just this function name value. Header's name equals value. And then we will send a message. We're going to send a message. Write. And what's it called? In the cache, it's called original response headers. Write original response headers. Oh, that's how I knew we needed to use visit original response headers. We're going to do write original response headers, and we'll pass headers. And then we need to accept this message in the parent. Moz cached HTTP parent. And over here we'll go case write original response headers. We'll go cache entry, and then there's this function called set metadata element in cache entry. capital D, element, pardon my belch there, and then this is the special key. Oh, and then we need to flatten it. Oh boy. So it actually needs to be a string. It can't just be this object. So what we need to be constructing on the other side is a string, I think. Message.data headers string. So let's go ahead and construct a string instead. Flatten network original headers. Take in some string buffer, and for each header, if entry.variety is a variety response, skip changed header, entry variety response. What does that mean? Skip a changed header. What does that mean? Mark has, if network headers change the header coming from the network, merge it. Original header. Oh wow. So for each header, append literal, colon, the name, the value, and then rn. Interesting. Okay, so that's what we need to do. Headers string. I don't think this is exposed to us. Flatten original header. No, it is not. So we have to re-implement it. So for each header, we're going to see if the header is of a particular variety. I don't think we can do that. I don't think we have the ability to look at the variety. So we might just be sunk there and we don't get to skip these. If the header name is empty, header name original. I think I'm just going to use the name. That's what I get with visit header. So I'm going to go headers string here's what I'll do. I'm going to make this be an array. Headers dot push a name colon space value, and then we're going to join with rn like that. We're going to call that headers string. Headers string. So that hopefully will work. Let's give that a shot. We'll go ahead and quit. Whoops. Go ahead and crash the process. Let's build. So let's go ahead and disable or clear the cache again. Make our first request. Also broken. What happened there? Did I... Something about what I did is no good? Like, did the... It doesn't get cached either. Did I miss a step here? Oh, okay. I have some actual source code error here. 865. You're upset about something. What are you upset about? Spurious. Spurious parentheses. Good job. Krita is crayon in Swedish. Oh, that's cool. Okay, so let's go ahead and clear our cache again. And did the image come in? There it is. Let's take a look at the cache now. And we'll try and grab. There it is. No header information, eh? Let's see if we can find out why. Go ahead and do that again. I'm going to open up this. I'm going to go into the debugger and I'm going to say header string. Process response headers here. Headers string. Did I write that? Headers string? Yeah, it should be headers string. That's good. So, well, first of all, that's wrong. That needs to be in the $sign wrapper. But also, what I'm going to do is I'm going to log header name value. I'm going to say processing response headers. So let's go to the console. Go ahead and clear the cache again. Do that. Processing response headers, and then not implemented. Visit original response headers not implemented yet. You know what I think the problem is that we're doing this in on start request. I wonder if this needs to happen later. Like, can I... What happens if I do this here on stop request? Am I able to iterate the headers later? Like, when... Under what circumstances would visit original response headers... Oh, and the other thing, I'm going to fix that. When would this be not ready? If there's no response head yet. Well, then how would we be getting the content type here? Let's see. Okay, go ahead and clear the cache again. Not implemented. Error not implemented. It's not available. It's not implemented. What does that mean? Null HTTP. Is it a null HTTP channel? Oh, is it an oblivious HTTP channel? It's not implemented. That's maybe why. Is that what it is? Is it an oblivious HTTP channel? That could very well be. That would make a lot of sense, I think. But then what do I do? is Oblivious HTTP channel. HTTP channel dot query interface ci dot NSI Oblivious HTTP channel. Let's go ahead and clear our cache again. Reload. Is Oblivious? Yes, it is. It's an Oblivious HTTP channel. That's what's going on. So I can't request the headers. Now, it does allow me to get a response header, but it doesn't allow, oh, and I can visit response headers, but not original response headers. So maybe it's fine that I'll just do visit response headers, because that's all that's available to me. Visit response headers. I'll have the Neko team examine this. Did that work? Okay, it worked. Now I reload, and it's broken again. Is it in the cache, though? Is the information in the cache? It is. So this was not enough. This is not enough. Even the fact that I set the content type, it's not enough. So I wonder if now what I need to do is set the security information. That could also be what's missing here. I also wonder if I can move this back to happening here. Let's go ahead and quit. Make sure that that still works. And then we're going to try and set the security information. Cache, clear. That gets our image. Then we try and do it again. It's broken. And cache on the disk. Here it is. There's our header information. Okay. So let's see what else we need. When we go here, we want security info. There's also these headers: strongly framed, Neko classified, strongly framed, request method, the response head. Maybe that's what it also wants back, is the response head. Which would kind of be a pain. But let's see. What would also be great is if there was like some kind of error message whenever we failed to get this image. Is there one? That would be really helpful. On data available, the binding aborted. On data available. Online 652. So by supplying the data that we got from the cache, we're getting this binding aborted. Well, here's the other here's the other thing. I'm realizing now, when we pull from the cache, we're just getting the input stream. So like, how are we expected when we stream from the cache? Do we need to somehow like adopt this pending listener starting request? When we pull from the cache, do we need to assign to ourselves like the content type, for example? That might be it. Because like what would be ideal is if the part that's throwing this binding aborted would tell us like why. Maybe if we go to about logging, we can log this stuff. Start logging. And then and we're going to stop logging. Is there anything in here about SVG? Frequency update. This is just about getting access to the cache entry. Not as useful as I wanted. Yeah, it's almost like what I want is the image decoder to tell me if it needs the well, like what it needs. What, you know? Now I'm just thinking, like, what uses this cache entry information? Original response headers. Is this just stored for just utility, or is it ever used? We get the metadata element. Keep them in order. We get the metadata element. Parse the string, and then what do? Get response head from cache entry. And we're going to put them inside of this response head. And what do we do with them? On cache entry check. If we were able to get, we're going to get a response head. Then what do? We're inside the channel. We assign it to the channel. We say that the channel mcache response head parse update headers. The response merge any new headers with the cached response headers. Update headers. So maybe what I need to do is set the headers on the channel that I'm creating. Because like whenever I try the cache, I'm going to create this input stream pump on this cached OHTTP channel. I think what we need to do is we need to like have the headers on this channel. Cached OHTTP channel. What does it implement? NSI channel. Do we ever get to the point where we're like trying to parse an SVG? Parse the SVG. That's what I want to know. Like, where is this binding abort coming from? SVG. Do those headers up top in the file get set by default if they aren't there? Do those headers up top in that file, which headers up in which file? I'm not sure what you mean. Like where it said content length equals -1. Where? Are you talking about in here? Where are you seeing that? I think it was in C++. Oh boy. Where could you have been talking about? Somewhere in here. Content length. Something. No sweat? Yeah. All right. Let me know if you spot it. I want to see if we are reaching the point where we're attempting to like parse an image. Where is like SVG stuff? Is that under like layout or is it graphics? Where's the SVG like stuff? Context. Because I know that exists inside of some SVG stuff. So now we're in Stylo. SVG. We're inside of Rust. Stylo struct. SVG image context. Now we're talking. Layout SVG. Do we ever get here? Start request. Layout SVG on start are on data available. No. Image loader? Do we have something called image loader? Data. Do we have anything in layout that's like dealing with on data available? Stream loader. Nah, it's more like it. Read segments. The input stream. Into something called write segment function. And then it's going to attempt to do this stuff. So let's see if we're actually entering this. How will I do that? I'm going to switch over to build with default. Let's switch over to a binary build. Normally I do this with a debug build, but I'm going to do it with a normal binary build. So we might have a little bit of a challenge ahead of us while we hop around because the code will be optimized. But at least this way you'll be able to get to see me do it, because instead of waiting for me to have a debug build ready. Now we have to. Oh, what was the? Here, I'll use this again. So let's double check, make sure this is broken. It loads, and then we do this again, and it's broken. Okay. So I want to now set a breakpoint inside of 47348. So sudo ldb. Oh, I think I screwed up my password there. 47348. Let's go ahead and zoom in. And where I want to try and break is here, stream loader. Okay. Aha, we hit it. Okay, so we are attempting to load this stream. That's good. And we are getting a segment. What is the contents? I don't know what this is. Highlighter. Right segment. This is not the segment I would have expected. This looks like unrelated stuff. Where are we? interpret, append child, post, load, style sheet. We're loading a style sheet. Okay, so this is less relevant. Continue. Huh. So never mind. Like, at least I think never mind. Let me try doing that again. Yeah, we're not hitting it. Right segment function. Stream loader on data available. Here? Is it, would we hit that? No. Break, disable 2, break, disable 1. Okay, so then where else might we be firing a binding being aborted? We haven't even gotten to the stream loader yet. Okay, well, break on NS Oblivious HTTP channel on data available. No? Is it Oblivious HTTP channel? What's it called? On data available. Yeah. Is there a namespace here? Is it in like Mozilla Net? Oh, okay. What? What? Doesn't know what I'm talking about. Am I spelling this right? Oh, casing. Lowercase t, t, and p. Oh, yeah, we never... No, we never reached there. We're loading from the cache. We never attempted to load from... break, disable, 3, 4, 5, 6, and 7. We're making... So, an image tag, image element. HTML image element. That's what we're dealing with here. Set source. Source set. Or source. Load. Is there something in here that's like start load? Aha. Start load. That's what I want. Start load. Start lazy loading. I want to begin loading it. Get source. Set source. What actually kicks off the loading of this thing? Force reload, update source sync, and queue image task. That sounds legitimate. Queue image task, image loading content. Queue image task, that's what I'm talking about. We're gonna try and image available, should load sync, is safe to run script. Then we're going to begin a new image load task. Element pending task, auto fallback. Suppressed. Run, pending fallback, merge, start, clear image, load selected image. Let's see. Let's see if we ever enter here. We do. PM source URI. What's it gonna be? What do you think you are? NSI URI. What? NSI URI, sorry, NSI URI. What are you? Couldn't look up the symbols. Okay. Doesn't know what it is. Okay, well, let's presume this is the one that we care about. Have source set or in picture. No. Triggering principle. If lazy loading, selected source or has source, we're going to try and load the image. Step. From node. Load flags. Pending event. Not document, get our owner document. Document, where are we in load image? Document is loaded as data. No. If a force or get the element, get the load. Image request proxy, prepare next request. What's this gonna do? Load image. Let's see where we're gonna eventually get to. We're inside of NS image loading content. Where's the thing that's actually going to make the network request? On data available on start request, NSI request. Here we go. Load image, values with the flags. Flags, load flags. What do you do with the load flags? Load flags. What are you going to pass that to? Into as content utils load image. Okay, going deeper. Going deeper, gang. And then we go into the image loader for something. Load image. We're going to make an image request. That sounds legit. Image channel. We're going to create an HTTP channel. Create the predictor. At some point, we're going to make an image request. Image cache validator, proxy listener. What is... Let's set a breakpoint here to start with. Nope. Okay. An image request. What is an image request? Image request. Let's put that here then. Load selected image. Image request on data available. That's what I'm talking about. So we're inside image request. So data has been made available. We're in here now. So it's somewhere. Is it here? Binding aborted? Or is that what we're hitting? Because something about succeeded is... What's the content type and create an appropriate image? That might be it. Get the image. P result. Succeeded is false. the result dot m image is a pointer. Finish preparing for new part. But something is wrong. Probably a content type issue. Content type issue. So something goes. It is what I suspected. We wanted the content type, I think. So succeeded comes from result, which comes from prepare for new part, which comes from this request. We're going to query. We're going to ask for the content type. Okay, I have a theory. I have a theory. Let's set a breakpoint. Moz cached OHTTP parent, Moz cached OHTTP channel. I need the channel. Multi-process cached OHTTP protocol handler. Get content type. I'm gonna log this. Accessing content type. And then this dot content type. That's what I'll do. And now if I do our thing, accessing content type, blank. That's what's going wrong. Okay, so now let's do something a little hacky. Let's do something a little hacky just to see if this fixes it. Is if the content type, we're just gonna say the content type is, where is it? We're gonna just return by default. We're gonna have the content type be image / SVG XML. It's really hacky. But let's see. Are image and document mutually exclusive? Yes, I think so. A document can have many images. They are not there. Well, that's the relationship. A document can have many images. One document, many images. I'm pretty sure that's the relationship. Okay, so let's try and load our thing. Hey, it loads. Hey, it loads again. That is the problem. Okay, we need to cache the content type. Not only do we have to cache it, we need to represent the content type. And you know, we were already doing the work with the content type by setting it on ourselves. We just weren't caching it. We weren't caching it. So what I think we should do is cache the content type. So what we'll do is we do this correctly. We're going to pull it out of the cache correctly. And then when we pull from the cache, so I'm going to undo this thing, this hard coding. But when we pull from the cache entry, we need to try and get the content type out. So in NSI cache entry.idl, we were writing the response headers. We can do get metadata element. Oh, that's even better, is that we can set content. Available types are defined at the beginning of this file. The content type is used internally for cache partitioning. Okay, not quite what we want. We're going to get the original response headers we're then going to split it up and pull out the content. What would be nice if we could like parse the headers. MDN header parse. Is there like a headers? MDN headers. I think there is. Headers. So like if I do what are the, is there like a toString for these things that works nicely? Like let h equals new headers, h dot set content type xyz, h dot set Mike the best, h dot toString. Okay, h dot entries. That's just going to give me an iterator. Is there a way to parse? What does the constructor take? Does the constructor take init? An object containing any HTTP headers. This can be a simple object label with string values, an array of name value pairs, where each pair is a 2-element string array or an existing headers object. Okay. Okay. So I want to pull. Oh boy. I kind of want to move the logic now for each of these headers. For writing these, I'm going to want to move this logic. What time is it? Oh, we're over time, but I want to get this to work. So is a headers object structured clonable? Clone H. No, headers object cannot be cloned, so I can't send it up in the raw, but I can send up an object. Okay. So that's what I'll do. Headers name equals value. Headers obj equals headers obj. I'll just call it headers obj. And then over here, what we're going to do is let h equals new headers. We're going to message data headers obj. And then for each entry, h.entries, not quite. I want to like do a key value thing like I was doing. What's a handy way of doing this transform? I'm gonna get this down into okay, well, for let entry of headers, an entry is going to be h entries. Sorry, the first one, it's going to be, what, h is, come on now. So it's a 2, okay. So let key value of headers dot entries and then we'll say header string equals that, header string, headers string, equals, oh no, we'll do the thing we did before. Headers strings dot push, and then key value, and then headers strings dot join. What was it? Join RN. And the reason to do that is so that when I might want to factor this out into a utility or something so that it can live alongside it. This is basically a serialization. I want to do a deserialization when we pull from the cache. Open cache entry. Try cache. We're going to open the input stream. So here, we're going to try and get let headers equals cache entry dot get metadata element original response headers headers strings dot split RN, and then let header string of header strings, let key value equals header string dot split, except there could be colon. Oh, multiple colons. You want to split on the first colon. Split. String split. Divide string into an orderless split string object. I want to just split on the first one. Limited split looks for spaces in the string and returns the first 3 splits. So the third one is the limit. You can specify a limit. A non-negative specifying a limit on the number of substrings to be included each occurrence, but stops when limit. So two. And whenever I do the set metadata, we're doing key. Is it, there's a space after? We should check. Is there a space after? Original response headers. What are they doing? Do they put a space on flatten? Yeah, space. Okay. So we're going to split on the first one. That's like that. And then we're going to let headers obj equal that. And we're going to headers obj key equals value. And we're going to pass down the headers obj to try cache. Strings. Headers strings, headers string, headers string, headers obj. Okay, and then that'll come down and try cache. And then down here, the result, if result success, create input stream pump, stream from cache. This dot apply cache headers. This result dot headers obj. Let headers equal new headers. Result dot headers obj. Apply cache headers. Headers. Okay, and then let's see if we can do that. Headers. Headers. This dot content type equals headers dot get content type. Now, is it case insensitive? Let h equals new headers, h dot set content type image slash svg. If I get content type, yeah, good. Okay, so we're gonna get that, and then let's see if that fixes it. Let's see if that fixes it. If it does, we're in good shape. Split isn't doing what you think there. I would like a cookie. Split. Oh, snap. Oh, thank you. That might be, I'm going to show you what we're talking about here. This is what is coming in from no IO before bedtime. Woof, that's not what we want. That's not what we want. We want everything after the first space. So really, you want like, I don't want to use regular expressions for this. There's got to be a simpler way. JavaScript string split after first occurrence. Split. Use capturing parentheses. You do index of and substring. Yeah, that might be best. So if you've got test 1 2 3 1 2 3 4 4 5 dot split. No, sorry, substring. Let x equals that. X dot substring x dot index of +1 +2, really, because you want the end of that. Okay. And then you want everything before. Yeah. Okay. Okay. So let's do one last thing here. So instead of splitting like this, thank you very much. No IO before bedtime. We're going to get the const delimiter equals, and we're going to go let key equals headers string substring 0 header, let delimiter index equal headers string index of delimiter index, let value equals headers string dot substring delimiter index plus delimiter dot length. All right, see what that does. Thank you very much. No IO before bedtime. Got our SVG. Oh, it's broken. No. What's going on here? Did we not cache the content type? About cache. Disk. What are you again? Content type. All right. And then in the parent, let's see if we can figure out. Okay, here. Headers obj. Oh, see, that's no good. We're substring. I did it wrong. Let's try it again. So I did the string stuff wrong. So instead of headers string dot substring delimiter index, and then probably delimiter length, probably, right? What is it? Substring delimiter index headers string. And then what's the key? Hang on. What's the key? Accept ranges. So really I want delimiter dot length. Oh, not quite. I want, what's the definition of substring index of +1? So string index of +2. So x delimiter index +2. Right. What is delimiter dot length? That's what I want. What's plus? Oh! Ah! That needs to not be in all caps. Let's try that again. I could probably clean this up a little bit, but I'm feeling pretty good. There's the image. There it is again. We did it. Yeah. Okay, and this feels like something I can write a test for. I'm going to do that not during the stream though. We've got it working. Phew, 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 phew. Still a vacation brain, 100%. My brain, I'm still coming back up to speed.
It's me, Mario.
Special shout out to No IO Before Bedtime and Craig and Smurf D and everyone in the chat who helped me out with that. I think No IO Before Bedtime saved my bacon with that that split thing, because that probably would have worked for the simple case, which is like a single string without any colons in it, a colon or space in it. But it would break if there was like in a subtle way, if there was like a header value that had a colon, like the delimiter existed in it. So huge shout out there. I'm going to call it. Hey, thanks so much for watching. I'm going to eventually get this up for review. I'll tell you what, I don't have a bug filed for this. Let's file a bug real quick, and if you want, you can follow along. And so let's file a bug for this. That depends on this bug. Moz cached OHTTP channel should set content type on itself when pulling resources from the cache. We at load time, when getting the image over OHTTP, getting, for example, an SVG image over OHTTP, we correctly set the content type on the channel by reading the content type header from the Anasai Oblivious HTTP channel. When, however, we pull the image from the cache, we do no such thing. We actually haven't been, the existing implementations have not been, existing implementation has not been caching the content type, which it should. And when we pull from the cache, we should update the content type on the channel to match it. So there we go. Gonna follow along if you want. I'll put a link to this bug here. And I'll try and get my patch polished up, maybe write a test, and then you can follow along there. Hey, thanks so much for watching episode 411 of The Joy of Coding. I hope that was interesting. It's still a little bit of vacation brain, but I'm back. Let me know what you thought. There's a link to rate this episode here in this form, or in the agenda. I'll put a link to that here in the chat. Link to rate this episode. Please fill out that form if you would like to let me know what you thought of the stream. If there's like stuff you want to see, stuff you want to see less of. Maybe you found this really boring. Maybe you didn't like the drawing I was doing. Maybe you'd prefer I don't know. Maybe you prefer me to just talk and draw and stuff. You'd like some lectures and tutorials on various things. Let me know what they are. If you have just questions, you can send them in during the forum, with the forum as well. I'll do my best to try and answer them if I have answers. And if you have questions about OHTTP, I can try and answer them there as well. And with that, I think we'll call it there. Thanks so much, everybody. Have yourselves a great week. I will hopefully see you next week. Take care, everybody. Bye-bye.
The joy of coding.
See ya.